Nothing is stopping you from going faster than light. The universe is stopping contradictions. There's a number you've been taught not to question. 299,792,458 meters per second. You were told this is the speed of light, the fastest thing in the universe, and that nothing, absolutely nothing, can go faster. Most people accept that immediately, not because it feels intuitive, but because it sounds official, like a rule written into the fabric of reality, something you're not supposed to argue with. But here is the uncomfortable part. If this were just a speed, it wouldn't behave the way it does. In your world speeds ad, you walk forward on a moving train, you go faster. You throw a ball from a moving car, it goes faster. That's not philosophy. That's how motion works everywhere else. So what's different here? What reaches into the universe and says, no further? And if your instinct is to answer with words like energy, or E-mass, or E because Einstein said so, pause for a moment. Those aren't explanations, they're placeholders. They let you stop thinking before the real problem shows up. Because the moment you take this limit seriously, something far more disturbing appears. It isn't motion that breaks, it's cause and effect. And once that starts to wobble, reality itself is on the line. So instead of memorizing the rule, let's ask a more dangerous question. What kind of universe would need this limit to exist at all? Imagine this. You're sitting inside a perfectly smooth spacecraft, drifting through empty space. No windows, no vibration, no engine noise, nothing to suggest motion. If you didn't know better, you'd swear you were standing still. Floating in front of you is a simple device, a flashlight. Ordinary, familiar, you press the button. A short pulse of light shoots forward into the darkness. You measure how fast it moves. The number comes out exactly as expected, the speed of light. So far, everything feels normal. Now imagine the spacecraft starts to move, at first gently, then faster. Faster than any plane, faster than any rocket. Eventually, so fast that from the outside, stars stretch into thin lines. Inside, nothing changes. You still feel at rest. You turn on the flashlight again. Your intuition doesn't hesitate. If you're already moving forward and you send light forward, the light should move faster. Just like throwing a ball from a moving train. Speeds ad. That's not a theory. That's everyday experience. So you measure it again. Same result. Exactly the same. You assume something went wrong. Maybe the device isn't calibrated correctly. Maybe the motion of the ship interfered with the measurement. So you repeat the experiment. You go faster, much faster, an absurd fraction of the speed of light itself. You shine the flashlight forward again, same number. You slow down, turn around, shine it backward. Same number. At this point, something feels off, not dramatic, just quietly wrong. Motion is no longer behaving the way motion is supposed to behave, so you try to save your intuition. Maybe the light source behaves differently when it's moving. Maybe the measuring process is flawed. Maybe there's some hidden delay you didn't account for. So let's remove all of that. Imagine another spacecraft watching you from the outside, moving differently. They run the same experiment. They shine their own flashlight. They measure its speed. They get the same result too, no matter who measures it. No matter how fast they're moving. No matter which direction the light travels, the speed stays the same. This is usually the point where people shrug and say, light is weird, and move on. But that response skips the real problem. Because if light behaves this way, then the universe has to rearrange itself to make that possible. You don't get one strange exception without consequences. If speeds don't add the way you expect, then something deeper has to give. Either space isn't what you think it is, or time isn't it, or both. And if you're feeling slightly uneasy right now, that's a good sign. It means your intuition is starting to notice it's out of its depth. This is usually where people reach for something solid, something familiar, something that sounds like an explanation. And if you're honest, you probably feel that urge right now. You want a mechanism, a force, a reason you can point to and say, that's why this happens. So let's try the obvious ones. Maybe it's energy. Maybe objects just need infinite energy to reach the speed of light. That sounds reasonable. In every other situation you've ever seen, more energy means more speed. Push harder, things go faster. But notice what actually happens here. You can keep adding energy. A little more, then a lot more, and the speed refuses to respond the way it should. It doesn't climb. It doesn't inch closer in any intuitive sense. The rule itself doesn't bend. So energy doesn't explain the limit. It only describes how you collide with it. All right, maybe it's mass. You've probably heard this explanation before. Massive objects can't reach the speed of light, while light can because it has no mass. Again, that sounds explanatory, until you stop and ask the dangerous question. Why should having mass prevent something from reaching a certain speed? What is mass actually doing that enforces this rule? In every other context, mass resists acceleration, but it never forbids it outright, until suddenly here it does. So mass doesn't explain the limit either. It just tells you who feels it first. At this point, many people quietly give up and say, "Gee, that's just how the universe is." And that isn't entirely wrong, but it isn't understanding, because notice what's happened. Every explanation you reached for came from the same place, everyday intuition. Rules learned from pushing objects, throwing balls, riding in cars. Rules that assume space and time are stable backgrounds where motion simply plays out. This limit refuses to live there. And here is the uncomfortable realization. If the speed of light is the same for everyone, then the universe cannot be giving all observers the same space and the same time. Something has to give. And that's where intuition finally breaks, not because the math is hard, but because the picture you've been using no longer applies. If that feels unsettling, good, that means you've reached the edge of the old model. And that's exactly where a new one has to begin. So let's stop trying to fix the problem using the same tools that created it. Instead of asking what force is stopping us or what energy we're missing, let's change the question entirely. Let's ask what kind of world would make this limit unavoidable. Right now, without realizing it, you probably picture motion like this. Space is a stage. Time is a clock. Objects move around on the stage while the clock ticks in the background. That picture feels natural because it works in everyday life. It's how your intuition learned to survive. But it teaches not the picture the universe is using. Imagine instead that space and time aren't separate containers at all. Imagine their directions, different ways of moving inside a single structure, not metaphorically, literally. Think of a flat map. You can walk north or east. If you start walking faster north, you don't also get faster east. You're not creating extra motion. You're redirecting it. The total amount of motion you have stays the same. You're just choosing how to aim it. Hold on to that idea. Now replace north and east with space and time. In this picture, every object, everything is always moving through space-time. Not optionally. Not sometimes. Always. When you're sitting still in space, all of your motion is aimed along the time direction. That's why time passes for you. You're moving through it as fast as possible. When you start moving through space, something subtle happens. You don't gain motion. You redirect it. Some of what used to be motion through time becomes motion through space. This is the first piece of the new model. And it already feels strange, because in this picture, nothing ever truly speeds up or slows down in a total sense. Everything always moves through space-time at the same overall rate. What changes is how that motion is divided between space and time. Now pause. This single idea explains something that felt mysterious before. If there is a maximum total amount of motion available, then there must be a trade-off. You can't increase motion through space without decreasing motion through time. You can't do both at once. That trade-off is not enforced by a force. It's enforced by geometry. And that geometry has a conversion rate between space and time. We call it the speed of light. This is the first major reframing. The speed of light isn't telling you how fast light goes. It's telling you how space and time are stitched together. Once you see that, several things fall into place at once. Why does light always move at the same speed? Because light doesn't move through time at all. All of its motion is aimed entirely through space. It's already maxed out in that direction. There's nothing left to redirect. Why can't massive objects reach that speed? Because they're already using some of their motion to move through time. They can redirect more and more of it towards space, but they can never redirect all of it. There's always some motion left along the time direction. And why does adding energy stop working the way your intuition expects? Because energy isn't adding motion. It's changing the direction of motion within space-time. Now let's push this picture one step further. Imagine two observers moving differently. One is drifting calmly through space. The other is racing past at enormous speed. They don't agree on how space is divided up. They don't agree on how time is divided up. They don't even agree on which events are simultaneous. And yet, and this is crucial, they agree on the structure underneath it all. They agree on the space-time equidistance between events. They agree on the rules. They're just slicing the map differently. This is why no observer gets to claim they're truly at rest. There is no absolute rest, because there is no absolute way to separate space from time. That separation depends on how you're moving. And now we reach the point where intuition collapses completely. Here it is. Nothing is trying to stop you from going faster than light. There is no cosmic speed limit sign, no invisible wall, no emergency brake hidden inside matter. The universe is stopping contradictions. If you could outrun light, different observers would disagree about what happened first. An effect could come before its cause. Cause and effect would depend on who was watching. Reality would lose its ability to tell a coherent story about itself. So the limit isn't there to restrict motion. It exists to protect causality. And once you see that, the speed of light stops looking like a number. It starts looking like a structural feature of reality itself. At this point, this can start to sound abstract. Space-time as geometry, motion as redirection, limits enforced by consistency. So let's bring it back to the real world. Every time your phone tells you where you are, it's using signals from satellites orbiting thousands of kilometers above Earth. Those satellites carry clocks, extremely precise ones. And those clocks do not agree with clocks on the ground. Not because they're broken. Not because engineers made a mistake. But because they're moving differently through space-time. Their motion through space slightly reduces their motion through time. Exactly the trade-off this picture predicts. If engineers ignored that effect, if they treated time as universal and absolute, your Jeep's location would drift by kilometers each day. Not eventually, immediately. So they don't ignore it, they correct for it. Constantly. The same structure that keeps light's speed fixed is quietly built into technology that works or fails depending on whether reality is treated the way it actually is. This isn't philosophy. It's operational. Once you really accept this, it doesn't stay confined to physics. Because the speed of light isn't telling you something about light at all. It's telling you how the universe avoids contradicting itself. There is a maximum rate at which causes can produce effects, a fastest possible way for influence to spread, not because signals are fragile or information is slow, but because without that limit, reality couldn't stay coherent. Different observers wouldn't just disagree about measurements. They would disagree about events, about what happened first, about whether something had already occurred or not. That's not a strange universe. That's a broken one. So the speed of light isn't a challenge to overcome. It isn't a wall waiting to be smashed. It's a safeguard. Here is the unsettling part. The universe doesn't run on forces first. It runs on constraints. Forces operate inside the rules. But the rules themselves, the structure of space-time, the ordering of cause and effect come first. They don't ask permission. They don't explain themselves. They simply are. And once you see that, the speed of light stops feeling like a limit imposed on us. It starts to feel like the reason the universe can tell a consistent story at all. The strange thing is, none of this feels dramatic in everyday life. You don't feel space-time shifting as you walk down the street. You don't notice causality being carefully protected when you flip a light switch. The universe does all of this quietly, almost politely. But the next time you hear someone talk about breaking the light speed limit, pause for a moment. Ask what's really being challenged. Not a number, not a piece of technology, but the structure that keeps reality from contradicting itself. Some limits aren't obstacles waiting to be overcome. They're the reason anything works at all.